going to pick up where we left off last week. After our quiz, I asked you to define a few terms, and I'd like to go over those definitions with you now and continue our lesson. Term. Term is a number or a variable or the product of a number and one or more variables. I could have this is an expression that has three terms. 6x squared is one term, 3x is the second term, and negative 2 is the third. In this particular expression, there are no like terms. Like terms have the same variable factors. They have the same variable raised to the same power. 9x minus 2x are like terms, and they can be combined because they have the same variable term raised to the same power. Coefficient is a numerical factor. It's the number that is before the variable. So I may have negative 5x squared, and the coefficient is just a number. It's negative 5. If you had x to the third power, the numerical coefficient there is 1. Constant. Constant's just a number. It has no variable attached to it. Any number is a constant. And then we look at the distributive property. It's used to simplify products, the product of a number and a sum or a difference. So I might have something like 7 and then x plus 6, which is now the product of a number and a sum. Or you could have the product of a number and a difference. Now, an algebraic expression is considered to be in simplest form when there are no like terms left and there are no parentheses. We then had a couple of problems to practice, and after looking at the homework, I saw that some people were not necessarily following through with the distributive property. You'd need to multiply that outside factor times both terms. This will give you 3x plus 24. The one on the right, I'm distributing a negative, which multiplies by 7 and also changes the signs. Second row, I'm multiplying, and this time that outside factor is on the right instead of the left. You're still multiplying. You'll get 1 2/10 plus 3 3/10 x. On to the next. Multiplying twice, this will give me 36 minus 2t. And the last row. This one says let's multiply by a negative, which means we're considering property of opposites here, which is as if we're multiplying by -1, and that just simply changes the signs. Last one has a negative as well as a variable. So sometimes it's not just a number factor that we're distributing. Remember, when you're multiplying, an x times an x will give you an x squared. That's when your exponents change when you multiply. So I'm going to change my signs and multiply by 7, add my exponents, change my signs, multiply, and add exponents. And that's your distributive property. Now, when I'm thinking about fractions, okay, remember that they're a grouping symbol, that fraction bar. So that when I'm looking at a fraction, say a over b, it could also be written as the multiplying by its reciprocal, because when you think about the division rule, it says to multiply a number by its reciprocal. So we can use that fact as well as the distributive property to rewrite some of these problems. Again, this 5 needs to be shared in both directions. Okay, so I could have 5x divided by 5 and 10 divided by 5. Now I can simplify the right side here, so I'm going to have 5x divided by 5 plus 2. So you see that sometimes I can use that distributive property to simplify, because again, this fraction bar is considered a grouping symbol. Let's test out a few of these. Now, you don't necessarily have to rewrite them as I did in the previous one, but you can simply just think about sharing them. So again, let's simplify this. 6x divided by 3 would give me 2x. And 15 divided by 3 is 5. If I wanted to simplify it, and again, a lot of times we look for shortcuts, this is exactly what I did to get to this end result. Let's look at the next one, and again, I am sharing this, distributing it to both parts. I have 12x divided by 3, which will give me 4x, and a negative 3y. In this last one, I want to remember my rules because, again, I'm dividing by a negative. So this would be 28x divided by negative 7. So that's going to give me a negative 4x. And then here I have this 21 and negative 7. So that's going to give me a positive 3. So that's just extending our distributive property into problems that look like this. Now let's talk about simplifying. Now remember that I can name some things. I can say that this has coefficients, which are 8 and 2. It has like terms because they both have x squared. And the question is can it be simplified? Well, using that distributive property, technically this is what I'm doing when I combine like terms. I notice that they both have an x squared. If I use that distributive property sort of in reverse, I have the 8 plus 2, which is 10. So basically, if the variables are like terms, you can just simply add or subtract your exponents. I'm sure most of you don't think of it as taking it apart, but that's basically what you're doing. So if you had a negative 7x plus 5x, these are like terms, you're simply taking that negative 7 plus 5, and that gives you your 2x. Do you have to take it apart? No, but that's just generally showing you what you are accomplishing while doing that. Simplify if possible. If not, explain why not. Try these 3 problems. These 3 problems will be something we'll cover in today's session. And just to let you know, you may have seen it on the calendar already, we'll have a test this week on lessons 1-1 through 1-7. I'll see you in class.